All right, guys, welcome back to another episode. So today we're talking about tuning and the process of tuning in a new material, maybe in a new nozzle size, a new temperature for a new production process, whatever it may be. There's a lot that goes into prepping for printing your part, especially when it's a brand new material, especially in higher temperature materials, and if you're trying to optimize the process. So today we're actually going over how we did this part, which we'll have more videos on in the future. This was for Reed Co. over at Tweedler Performance. Gave us permission to feature this part, and we just spent a couple days trying a bunch of different options to see how fast we could print it in adequate quality, so it looks nice enough and it will be post-processed, and out of a material that will be strong enough and high temperature enough to go on, I believe it's a throttle body intake elbow. So this is going inside of a car, and he's producing these en masse on our 22IDEX 3D printer. If you haven't seen that yet, check out visionmatter.com/22IDEX. Lots of cool stuff coming. But we thought it would be a good test to start tuning in new profiles and everything on that machine. And for this, we used carbon fiber high temperature nylon, and really great material. It's incredible how strong it can be and how temperature resistant it can be. We see a lot of automotive applications, but I digress. Today we're talking about what it takes to start with a new material on a new machine with a new nozzle size and a new hot end and all the different variables that go into making something work on an FDM or FFF 3D printer, which is really a glorified robotic hot glue gun. The quality of your part in the end is really based on the application and need. How good does it have to be? With PLA and PETG and comparatively easy materials, that's definitely something to go for. You can get beautiful prints that are perfect all the time, but when it gets into the industrial applications, we need to solve a problem. We need to make something work where we need it. And so that often means we don't necessarily have to worry about little aesthetic things like this, where maybe there's blobs and zits on the side, because we're actually going to sand this or coat it or vapor smooth or something like that, or maybe it's just going inside something and it's going to be covered, and so it doesn't even matter how it looks. So there's a lot of considerations as to how good you need it to actually be in the end, and that will shorten or lengthen your tuning process. Now, for a lot of things, if you do need it to be perfect, you're either going to have to go to post-processing or use a different process. And for a lot of things like SLS or SLA can be great for getting that perfection and that totally awesome surface finish. By the way, if you're not already subscribed, stay tuned and hit that big red button, because we've got some amazing content coming on selective laser sintering or SLS polymer printing. It's going to be awesome. I can't wait, but that technology would make this basically a breeze and look exactly like the 3D model and require very little post-processing. But let's dive right in and sort of look at what this process consisted of, and we'll start going through the list. We had the first one. We had the guys, all right, throw it in there, put it in at the standard settings, so maybe it was like 340 Celsius on the nozzle for CFHTN, and at 100 millimeters a second. Let's try that, or 300, or whatever they were doing. They let it print for about 10-15 minutes. We started to notice that there was some under extrusion on the tops. We're like, okay, let's look at speed, let's look at retraction, let's look at the the filament pathway and make sure everything's flowing nice and going, everything's making it around all the corners well. And then let's actually take it and let's twist it. Oh, as you can see, layer adhesion was not there. It was just not working. So clearly we need to adjust temperature, speed, something to figure it out and make it actually work. So in the second rendition, we got I think we increased the temperature, might have slowed it down a little bit, and when we broke it, I mean, as you can see, that's got a lot better layer adhesion, and it didn't split apart like spaghetti or like a slinky like the previous one. So, okay, better layer adhesion. And so from there, we went on to change some more settings, and we got it to the point where, okay, it's looking a little bit better on the bottom layer, still a little bit messy on the inside, but it's got pretty good layer adhesion. But then, okay, the supports aren't necessarily sticking there. But that really led us to the fourth print, where we realized something else was wrong. And this really came down to under extrusion. We were going too fast, and certain ways that we had the filament tubes set up and whatnot, there was a little bit too much friction going on, so it was having a hard time feeding, and so we changed all that and started addressing those issues before moving on to number 5. And at this point, I think someone realized the nozzle size was actually being miscalculated in the slicer, and so we changed the nozzle size to match what it was supposed to be, and that started getting better results. So you can see on the inside, it started getting a little bit better. The layer adhesion was better, as you can see from this break here. It's a pretty solid break, still not quite where we want it, so speeds and temperatures for that to get that a little bit better. And we just kept going to where, okay, now we've got a part, and it's strong, it's really stiff, everything's adhered really well. Yeah, this stuff is strong. Carbon fiber nylon, dude. High temperature carbon fiber nylon. It's very, very good stuff. This started looking a lot better. All right, looks like we've got some, it's strong, it looks pretty good, and let's just keep dialing it in, try to get these top layers a little bit better. And then we kept going, okay, the bottom layer's looking good, top layers are good, or pretty good, but still a little bit messy. All the way here at the end, you can see it's solid. There's a lot of material in there, but it's bumping up and over. So it's not perfect, it's not right flush the way we want it. So they went through some of the different things, and we can see here was one of Cole's renditions, and you can see there, it's got very nice, just little gaps on the inside, definitely a porous structure, but good enough for the application most of the time. This is a 0.8 millimeter nozzle, and I believe we ended up at like 70 millimeters a second or something like that with 0.25 or 0.3 millimeter layer heights to try and crank them out fast. We got it under 11 hours for this part, I believe, with supports. You can see in the top layer, okay, they started tuning that in, dialing that a little bit better. And then over here, we've got some notes here. We've got 75% or 75 infill on this one, and then we got the extrusion. So 70 infill and 75 infill. Whatever that was, they were writing all this stuff down. And slight changes in between, but you can see this part here is a little bit more solid with it all, all the different lines touching the different lines and outline overlap and all of that. Like I said at the beginning, it depends on what is actually needed in the end. So something like this, having a little bit of extra material sticking out might even be a good thing because you just have a more solid part, but you don't necessarily have to worry about it at a certain point. Good enough is good enough. Is it strong? Is it going to stay together? Am I going to bolt this onto the car and it's going to last? It's going to be a solid part? Yes. Okay, sweet. Let's move on. We don't need to spend too much time in minutia dialing this one single part in to make it perfect. You can, but our customers are making money. Our customers are making products that are being sold to end users, and they need to fulfill a function and purpose, and that's what you should focus on to get the thing out and be done, and that's what these machines are for. If you need perfection, again, there's other processes, whether it's injection molding, CNC, SLS, SLA, etc. It all depends on the application. So, some extrusion multiplier stuff done here, and then we get into a little bit more complex stuff, which is overhang, and the style of overhang. So it's starting down at this end over here. We can actually see that halfway through this process, they changed the support style. So here, we actually had straight support lines that were building up, and I believe this actually printed this direction. So this stuff in the middle here was printing up over this overhang in order to then support the full part when it came up, but we stopped it. We kept stopping it because we actually cut this part off a little bit lower. So as you can see, there's no flange on the bottom of this part. That's actually a huge tip, guys. When you're tuning, don't print your whole part to tune every single time. Cut your part into pieces, or just drop it down lower in the build plate to print the area that's giving you challenges, and then print that area over and over and over until it's acceptable to your needs. You don't have to print the whole 11 to 24 hour print every single time. You can do iterations very rapidly in the 10 to 30 minute range, and you'll get to the final product much, much quicker. Now, so for this one, let's look at this. If I look at the bottom of this part, obviously that's a very nasty overhang. We wanted to make that a lot better. So there's a couple ways we could do it. As you can see here, there's gaps in between each thing. So they switched it and they went directly to this type of infill where the supports actually are cross-hatched. It's a grid pattern. And that just helped get a little bit more surface area on the parts that were needed. And these aren't actually in the particular order because I just grabbed the box and I was like, I gotta talk about this right now. I gotta show people what we're doing here in the shop every day. And you can see the support's definitely much better. If I compare those two, I mean, that's a night and day difference. So as you can see here, there's a variety of different levels of quality that were achieved based on the settings they chose and they experimented with. But from the beginning, we were like, we need this good enough to be solid and strong and high temp, and then post-processed, and I believe he's gonna be doing a full coating on these after a little bit of sanding. So, you know, an overhang like this isn't actually gonna matter because they're gonna sand it and then it's gonna be covered in like epoxy or something like that. So this is more than good enough for the actual application at hand and the final product. So that being said, really don't kill yourself when you're tuning. Get it good enough for what you need to do and then run with it. This is an amazing process that gives you all these different options and you can really, you know, do a lot in a short amount of time to make your parts better. So a couple of the main settings you really want to look at are going to be temperature. You want to make sure you're getting good layer adhesion so you're printing hot enough. A lot of the times, especially if you're printing extra fast, the temperature on the box is not hot enough. And a lot of these materials can handle a lot hotter printing temps. PCTG, for example, prints around 240, 250 at 60 millimeters a second. A Centium, though, I believe is printing at around 800 millimeters a second, but they're printing around 300 or 400 Celsius, and it's about how long it's at that temperature, not necessarily about the temperature itself. All right, so you can use variable settings for different areas. You can tune in support interfaces, interface layers. Like on this, there's one layer of separation between the support and the actual part. If you're using multiple materials or soluble supports, you can do that with no layers in between, so you can get a much smoother surface. That being said, thank you guys so much for watching. Leave your comments down below. I want to know what questions you have, what you would like to print, and you know, what kind of things are you struggling with, or what tips and tricks have you learned about the tuning process? What did I leave out of here? What should I have said more so? Anyway, we love reading your guys' stuff, and we appreciate all the viewership. Make sure you're subscribed, and here at Vision Miner, all we do is functional materials and functional 3D printing, whether that's SLS, 3D scanning, FDM or FFF 3D printing, but high temp, PEEK, ULTEM, PPSU, carbon fiber, nylon, carbon fiber PEEK, all kinds of cool stuff, aerospace, medical, oil and gas. So if you got questions, reach out. We're always here to help. We sell complete systems and materials for anything you might need 3D printing related. Anyway, thank you so much for watching. Have a positive rest of your day, and I'll see you on the next video.